basically what we consider overlapping sets to be is a mixture between, two category sets, and then there's also three category sets, which is where we get into Venn diagrams. Now, sometimes people will use a Venn diagram for two categories. Personally, I don't think it's that necessary. I think it can sometimes be more confusing than it's worth. So today, we're going to do a lot of two category stuff. If we have some time, we'll do some three category stuff as well. And we'll do about 45 minutes again today, like we did last week, of problems and stuff like that. So to get everyone kind of warmed up, I'm going to start with a fairly basic problem, one that'll allow us to really kind of talk about and break down the idea of how these overlapping sets kind of operate. So with that said, I'm going to put the first question up, give everyone about 2 minutes, and then we can kind of talk about the result. Okay, so that was about 2 minutes, and this question is definitely, on the basic end of sets, and there's two ways to look at this. The nice thing is a lot of these are algebraic or formulaic, I guess is a better way to put it. So we know that in any two-category problem, the way it can be solved is you can say that the total is equal to, let's say, the number of total history plus the number of bio minus both, which is the overlap, and plus the neither. And if we do this out without setting up the chart, you see we have 50 students, history is 20, bio is 32, both is we're looking for both, so that would be minus b. And then the neither is 12. So if we do the math out here, we see we get 50 plus 52 plus 12. So if I just do that math there, 52 plus 12 is giving us 64 minus b. So we see b equals 14, which is what many of you had. Now, with that said, you could also set up a chart with your two different categories. So what are these categories? Well, we have bio, no bio, total. We have history, no history, total. We can say that there are 50 total students, so we put that in the bottom right-hand side of our box because that's the grand total. We have 20 taking history, and here's the best part. All the ends of our rows and the ends of our columns all sum together. So when you know there's a 20 here and a 50 here, we know that this is 50 minus 20, which is 30. So obviously you can do that math in your head. Then we have that 32 take bio, gives us an 18 of no bio, 12 take neither, and then you'll see we can just start filling in. We end up with 14 here. So like I said, that's a pretty basic one to start. We are going to get into some more difficult questions right now, and hopefully everyone feels fairly good about using the chart when setting up these questions. So let's go ahead and do the next one here, and I'll give everyone about 2 minutes. Okay, so it was about 2 minutes. So this is an interesting question here where you can definitely, there's two ways of looking at it. You can plug in real numbers if you want to. I say this a lot. I say this to all of my students. Anytime you have answer choices, sorry, everybody. Just a reminder, anyone who's on the webinar, please mute your microphone. Otherwise, it becomes pretty distracting. What I was saying here is that anytime your answer choices are in fraction, ratio, or percentage form like this, you always have the ability to plug in real numbers for for the totals in this case. So when it says on a certain airplane, 2/5 of the passengers are female, well, we ask ourselves 2/5 of what? And that's where we can start to plug in and be very strategic in what we're doing. And really, it's up to you. It's a personal preference. If you want to use variables, you use variables. If you want to plug in, you plug in. So I'm actually going to plug in here. And I'm going to first fill out my chart. We have male, we have female, we have total. We have likes, peanuts, no peanuts for dislikes, and total again. Now, strategically, because we have a fraction of 2/5, 1/8, and 1/2, it makes sense to plug in something that's divisible by 5, 8, and 2, which would be 40. With that said, we can now have at it. So when it says 2/5 of the passengers are female, we say, okay, what's 2/5 of 40? So you can either do that out or do it in your head, but we end up getting 16, which means we have 24 males. 1/8 like peanuts, that's 5. 1/2 of the passengers are males who do not like peanuts. Okay, so that goes in that circle, that's 20, which means we can start filling in here. 20 and 4, that would be 4. This would be 1. This would be 15. This would be 35. Now, some people get caught up at the end, and they get this part wrong. So you have to be very, very, very careful that you do things till the end. You know, I always like to say, don't fumble on the 1-yard line. That's what could potentially happen. So it says, what fraction of the total, the number of male passengers who like peanuts, which is this, is what fraction of the total number of male passengers on the plane, not total passengers. So that becomes 4/24, which becomes 1/6, and there is our answer. So hopefully that wasn't too bad for anyone. But what I want to do next is I want to get into what happens when we start dealing with algebra and overlapping set questions. So as always, fill in the chart. Now, someone just asked how we got 20. We got 20 because 4 plus 20 is 24. So remember, all of the columns and rows sum together. So why doesn't everyone take a stab at this here and fill the answer into the chat box. Okay. So hopefully this problem wasn't too bad for everyone either. This is using algebra in our set. Once again, everyone should notice we've got answer choices that are in percentage form. So we can plug in a real number when we finalize our set here. So we have our 3 rows. We have jacket, no jacket, total. We have tie, no tie, total. Now I'm going to say the total, the grand total here is 100. So when we see 40% of the guests wore both jackets and ties, we have 40. 50% of the guests who wore jackets did not wear ties. This is where everyone gets messed up. So the question we have to ask ourselves is, do we know how many people wore jackets? So we kind of take a look at this here, which is here, and we say, well, no, we don't know how many people wore jackets. So we put an X here. I'll change the color. I'll make it blue. And that represents the fact that we have no idea how many people wore jackets, so that means we can make this 0.5x, which means furthermore we can now make an equation. So yes, we didn't fill out the entire chart, but at the same time, you know, we really don't care whether or not we filled that out. And basically, 50% of the guests who wore jackets did not wear ties. Yes, so we are in good shape. So now we say that 40 plus 0.5x equals x. 40 equals, oh, I see. I am in a backwards column. I need to be in the tie column. Sorry. So let me just flip this around because, yes, we care about those who wore jackets. So one thing I needed to fix is this is x, this is 0.5x. So now we're all in the tie column. So 40% of the guests wore both jackets and ties. 50% of the guests who wore jackets did not wear ties. Oh no, I was good. Sorry, everybody. So we're good. So anyway, what we need to do is we need to finish up our math here. We have 40 equals 0.5x. Now, of course, we can make this 1/2 x. And we have 80 equals x. So the answer to this question, what percent of the guests wore jackets, is 80%. So I thought I had that backwards for a second, but I did not. So this shouldn't be too bad, and you shouldn't be concerned that we didn't use the whole chart. To be honest with you, it doesn't matter. It's just helping you organize information. I do the same thing with distance problems. I do the same thing with work problems, et cetera, et cetera. So something to keep in mind as you're moving forward doing some more of these questions. So I do want to do a really cool data sufficiency question with everyone. This is going to include some algebra in a similar fashion to what we just did. And I'll give everyone about 2 minutes, and we will talk about this. Okay, so that was about 2 minutes again there. So this is an interesting question because ultimately you are solving for something here, but it's not actually what you need to solve for. That's what makes this so hard. So we fill in our chart, and then there's also another component to sets with data sufficiency. It's how do you determine what you're using with statement 1? How do you determine what you're doing with statement 2? So there's a couple options. One kind of nice way to deal with these is you cut your boxes in half after you fill in the given information. So let's start off and fill in the given information, and I'll show you what I mean. So we have male students, we have female students, we have total. We have science team, no science team, total. So we are given that 40 female students are on the science team. So we put 40 for science team. And that's really all we have here. And we want to know how many male students in total are at the school. So what you can do next is you can really break each box into two pieces. The reason we do that, upper left is for statement 1, bottom left is for statement 2. Now, of course, I have the ability to change my color. Yes, it would be great if we could have multicolored pens on the GMAT, but heck, they're not giving us any breaks. So why would they ever want to do that? Well, they won't. So with that said, let's get into statement 1. It says 20 of the students who attend the school. So let's say that T is the total. So I'll remove the line there. 20% of the students who attend the school are not on the science team. So no science becomes 0.2 T, which again means this can be 0.8 T because the columns and rows have to sum together. So that's out. Statement 2, 40% of the students who attend the school are females on the science team. So that would be for statement 2 here. And remember, we need to solve for male students in the school. So that means we can say female science team is actually equal to 0.4 T. Now this is looking pretty nice because we can do some math, we can solve for something, but again, we have nothing here. We want to take this one step further and look at these guys together. Well, it doesn't matter because we still have no idea how many males there are at the school. So without that, there's absolutely no way for us to solve this. So the answer ends up being E as in Edward. So be careful. Just because you solve for something doesn't mean it's sufficient. Just because we know what T is doesn't mean we have an answer. And part of the time, they're going to throw at you, even in problem-solving questions especially. Like, I see this a lot in work questions or distance questions where you get an answer for time, but you need to then convert that to distance. Or even in a word problem, if you get Jack's age, but they're asking for Frank's age, you're going to have to plug in Jack's age to find Frank's age. They do this constantly. And then what happens is the trap answer is always there because 9 times out of 10, you're going to put the first thing you see on the screen, and you're going to think you're right, and you're going to move on like all is well, when in fact all is not well. So with that said, I do want to do another algebra type question, and then we'll move on to do a couple other things. We'll probably do 1 or 2 more questions. I did want to share with you another success story from the last week that everyone could read over. We're pretty psyched about it. Someone who used our course in a pretty short period of time. So with that said, just trying to find the right question I want to do with everyone. So we'll give everyone about 2 minutes again. This one's definitely a little bit harder, I'd say. A little bit more going on than the tie, no tie question. But same concept. You are going to have to use algebra here, so I will give everyone that hint. Then we can go from there. Okay. Give this a shot, or we'll talk about this in about 2 minutes. Okay, so it's again about 2 minutes there, and we can end on this problem here. This is another problem where you have to be extremely diligent in your process, and you have to make sure you see or deal with the final answer. So we have male, we have female, we have total, we have present, no present, total. So what we want to start doing is just start filling in. We have 300 guests. We have 70% of the guests brought gifts. So that is 210. Now, we know that the rows and columns sum, so here's 90. And then here's where the algebra comes in. 40% of the female guests brought gifts. Okay, well, we don't know how many females there are, so let's call that F. Let's say 0.4 F goes there, which means 0.6 F goes here. If 48 males did not bring gifts to the party, so male no gift becomes 48, And now we see that we have ourselves a nice looking equation here between this and this. So what we say is 48 plus 0.6F equals 90, and then we subtract 48 from 90, so we have 6F equals 42, and then we end up getting F is 70. Now, if you put E, you are not right. The question doesn't say how many females are at the party. The question says how many females did bring gifts. 0.4 times 70 is 28. The answer is B. So hopefully this provided some pretty good insight into how you can see overlapping sets. Hopefully this provided some pretty good insight into the fact that overlapping sets is really just, in some cases, a vehicle for algebra, as is so many questions on the test, like geometry as an example, or like coordinate geometry. Algebra is king on this test. So if you can deal with algebra after you get the proper setup, you can really blow this test out of the water. Now, as I said, I wanted to share with everyone a particular story that may be meaningful to all of you who may be thinking about your test or retaking your test. Now, I understand that this particular story is a turnover that happened in 10 days, so it was very quickly. The student had done a lot of prep leading up to this point, but it continues to kind of show what our course can do for anyone who has yet to even try it or use it. It can be customized to your needs if you're someone who has tried and failed with many other resources out there. And at the same time, if you're just starting off with your GMAT prep, it has everything you need too, and you can't necessarily expect a 10-day turnaround to get your score. But everything we're doing here in these webinars is really a microcosm for what we're teaching and for what you can do on your own time. The idea is to be very granular with your approach. You do not want your learning to be randomized, so if you are someone out there who is just throwing yourself into the official guide, and this is how you're doing the majority of your prep, just understand that the official guide is a very random book, and it's not necessarily something that can fully prepare you for the GMAT. So again, if you haven't given us a shot, we definitely welcome it. And finally, if anyone has any questions, feel free to reach out to me directly or Scott, our CEO, directly. We're certainly always around to help. So until next week, we want to thank everyone for coming, and we will see you again in a week, so next Tuesday. See everyone soon.